Every January, a small editorial team at MIT locks themselves in a room, argues for months, and produces a list that quietly reshapes how governments, investors, and engineers think about the next decade. Not a trend report, not a VC pitch deck. A list. The 2026 edition, now in its 25th year, includes something no previous list ever has: a technology used on a living human baby before it even had a name. That is not a teaser. That is item number 5, and by the time we reach it, you'll understand why it changes how medicine is discussed at all. But most videos miss what actually matters. They read headlines. We're reading the subtext, the footnotes, the parts that explain what is really at stake. 12 technologies, ranked not by hype, but by structural impact. Let's start. Number 12, sodium-ion batteries. This sounds boring until you realize it's geopolitically explosive. Sodium-ion batteries are made from salt, the same element on your table. Here's the problem they quietly solve. 95% of projected 2030 lithium-ion battery manufacturing capacity sits in China. That's not a risk spread across suppliers. It's a single point of failure for the entire Western energy transition. Sodium breaks that dependency. It's the 6th most abundant element on Earth. You cannot corner the market on salt. Global sodium-ion shipments hit 9 gigawatt-hours in 2025, up 150%. The market grows from about 1.4 billion to nearly 7 billion by 2030. CATL, BYD, and Hina are already producing at scale. Yes, energy density is lower than lithium by 20 to 30%, but for grid storage, where weight doesn't matter, that gap disappears. This is not a lithium replacement, it's a strategic escape hatch. Number 11, generative coding. In 2023, AI finished your lines like a smarter Stack Overflow. In 2026, it writes, tests, debugs, deploys, and then argues with you about architecture. MIT didn't include this because it's new. They included it because the inflection point just happened. 84% of professional developers now use AI coding tools. More than half use them daily. The market jumped from 550 million to over 2 billion in 18 months. Here's the uncomfortable part. Someone still has to check the output. AI-generated code passes tests it wrote itself. That's like hiring a contractor who also writes the inspection report. The real breakthrough isn't generation, it's the rise of AI code auditing. The companies building independent verification layers are the ones to watch. Number 9, AI companions. By mid-2025, there were 337 revenue-generating companion apps. 128 launched that year alone. Downloads hit 220 million by July, up 88%. MIT didn't include this because it's impressive. They included it because it's dangerous, and they said so directly. California's SB 243, effective January 1, 2026, is the first U.S. law setting safety standards for AI companions. Age checks, crisis protocols, and mandatory disclosure that the conversation is artificial. It exists because teen suicides were linked to these apps, because the top 10% capture 89% of revenue. Engagement is rewarded, well-being is not. MIT's line is blunt. There's mounting evidence this is dangerous, and politicians are finally waking up. That's not a warning, it's a diagnosis. Number 8, mechanistic interpretability. Here's the question nobody likes to answer. Do we actually know what's happening inside these models? As of 2025, barely. 91% of organizations doubted their readiness to safely scale generative AI. 40% flagged explainability as a major risk. Only 17% were doing anything about it. Mechanistic interpretability reverse engineers neural networks the way archaeologists reconstruct ancient languages, working from constructs back to grammar. Anthropic extracted millions of internal features from Claude 3 Sonnet, mapping conceptual relationships between tokens. This is early AI neuroscience. We found lobes, not understanding. Why does this matter more than anything else here? Because every other 2026 technology is built on AI we don't fully understand. Without interpretability, we're building skyscrapers on fog. Let's continue with number 8, hyperscale AI data centers. In 2024, Amazon, Microsoft, Google, and Meta spent $200 billion on data center capital expenditure. That's a 62% increase in a single year. These facilities already consumed 176 terawatt-hours of electricity in the U.S. in 2023. By 2028, that number is projected to reach 580 terawatt-hours, potentially 12% of all U.S. electricity. These are not rows of independent servers. They are nanosecond latency clusters that behave like one distributed supercomputer. The heat output rivals industrial plants, and the electrical grid cannot scale fast enough, which is exactly why the next item exists. Number 7. Next-generation nuclear reactors. The driver here isn't climate policy, it's data centers. Microsoft restarted 3 Mile Island. Google contracted Kairos Power. Amazon is funding X-Energy's TRISO reactor. Global nuclear capacity could nearly triple by 2050, from 377 gigawatts to 992 gigawatts. Traditional reactors fail when cooling fails. Fukushima showed that clearly. Small modular reactors using TRISO fuel are physically incapable of meltdown. The fuel is sealed in ceramic layers that contain failure by design. There are 127 designs in development, 51 already in regulatory licensing, and funding rose 81% in 2024 to $5.4 billion. This isn't a nuclear comeback, it's a different technology wearing the same name. Number 6. Commercial space stations. The International Space Station cost $150 billion and deorbits in 2030. NASA's replacement strategy is simple. Don't build another one. Instead, Blue Origin, NanoRacks, and Northrop Grumman received $415.6 million to build their own. Axiom Space's first module is already in orbit, the first privately owned structure in space. The first fully commercial station launches in May 2026. Microgravity manufacturing enables things Earth cannot produce reliably: near-zero impurity fiber optics, high-quality pharmaceutical protein crystals, and atomic precision semiconductors. The station isn't a hotel, it's a factory with the best view in the solar system. Number 5. The base-edited baby. In February 2025, a 7-month-old child named KJ received a therapy never before given to any human. KJ was born with a single faulty gene, fatal within months. Researchers designed a bespoke base-editing therapy in under 6 months. This wasn't CRISPR cutting DNA strands. Base editing converts one DNA letter to another without breaking the strand. Delivered to the liver using lipid nanoparticles, it worked. This treatment wasn't adapted from anything existing. It was built from scratch for one mutation in one patient. Personalized genetic medicine is no longer theoretical. It's becoming a repeatable clinical workflow. Number 4. Gene resurrection. Colossal Biologics has raised $435 million and reached a $10.2 billion valuation. Their goal is woolly mammoth hybrid calves by 2028, inserting 45 key genes into Asian elephant embryos using CRISPR. The result isn't a mammoth, but a cold-adapted elephant designed to help restore Arctic grasslands that lock away carbon. The larger story is pharmaceutical. Extinct genomes contain compounds unreachable by conventional discovery. The Tasmanian tiger's genome includes immune proteins with potential antibiotic properties. Gene resurrection isn't nostalgia, it's a library of solutions evolution already tested and humans erased. Number 3. Embryo scoring. MIT included this with the strongest ethical warning on the list.
Polygenic scoring can now predict cardiovascular risk, diabetes susceptibility, and aspects of cognitive ability in IVF embryos. Startups like Genomic Prediction and Orchid sell these scores directly to fertility clinics. The science is real, but limited. Intelligence scores explain only 10 to 15% of educational outcomes. They're probabilistic, not deterministic. The problem isn't the technology, it's selling correlation as certainty. No regulatory framework exists yet, making this the technology most likely to trigger legislation within the next 2 years. Number 2, agentic AI convergence. By 2026, 40% of enterprise applications are expected to include task-specific AI agents, up from under 5% 2 years earlier. These systems set goals, act across external tools, and self-adjust with minimal oversight. The risk few discuss is error propagation. When an agent makes a serious mistake, the question isn't just what failed, but which internal activation caused it and how to stop that failure from spreading across dozens of connected systems. We don't yet have that answer. That gap defines the technical tension of 2026. Number 1, the dependency chain. MIT's biggest story isn't any single technology, it's the chain linking all of them. Data centers need power. Nuclear provides it. Generative coding builds software. Interpretability makes it trustworthy. Agentic AI deploys it. Revenue then funds gene editing, space stations, and advanced batteries. This is one interconnected system, and the critical path runs through energy. Companies controlling AI compute and zero-carbon baseload power aren't just tech companies, they're infrastructure companies, and infrastructure is where generational wealth is built. MIT has been right more often than wrong for 25 years. The question isn't whether these technologies will matter, it's whether you'll understand them early enough to act. 12 technologies, one system, and a track record tied to the Internet, GPS, and the World Wide Web. MIT is also asking viewers to vote for an additional breakthrough, including reasoning models, artificial wombs, humanoid robots, and uncrewed fighter jets. Voting closes April 1st, 2026. Link in the description. If this breakdown added clarity beyond the headlines, subscribe.